Hello sir, good morning. This is my final project Kriging, and you can see here I just import libraries which library is need for this project like pandas, geopandas, matplotlib, and here I just set working directory and read files. Here we collected like from the field data, and you can see this is the small data set x, y, and z. Is elevation and x and y horizontal and vertical, and for example a is, you can see, small data set, and b is small data set here, and those are about like 4.43 meters. This point is located at the corner top left corner, and similar b, c, d, and f on, and here just we are use coordinate reference system EP SG26915, which is UTM John 15 N, and then plot the points on a map using matplotlib. Include a north arrow for orientation, and you can see in here just there is a scatter plot, and showing all the survey points on the ground surface, and x-axis is we have string in meters, and on the y-axis like the northing both based UTM coordinates, and blue dots represent a point we collected during the field survey. As you can see, the points are spread across a grid, and grid, and likely forming the boundary and interior and structure of our site. And we have also north arrow in the bottom right to help orient our viewer. North is pointing upward and slightly right, which means the top of plot aligns roughly an actual northern direction. And here you can see now we are preparing the data for interpolating and specifically for Kriging. And first you can see x and y and z values here, and especially extent of all points. That means that minimum x and y values on this frame. And using grid we assume like a specific 1 meter, uh, and like it checks whether an x1 y z areas are not empty, and we have matching length also, and we are preferring like ordinary kriging using different variogram, and then models to see which one gives like the best interpolation like a result. And then we are start like a linear power, and then Gaussian exponential, and like others one, and we can calculate a root mean and a squared error here. Um, and then you can see bar chart, this bar chart show the comparison between different variogram models and their prediction like error measured as RMSE, root mean squared error here. And on this x-axis we have the five variogram models, and linear power, Gaussian, exponential, spherical, and on the y-axis we have the error values, and you will notice it's in the range 1 to on 5, like which indicates exactly small errors. And from the chart, Gaussian gives the lowest error, and spherical and exponential. And here I just explain now, we are performing the final Kriging interpolation using the spherical and variogram model, which gave on of the best feeds and based on the RMSE compression. And we use the ordinary Kriging here, like x and y and z, our coordinate and elevation values, and then like videogram model is spherical, like telling the model how to estimate an special relationship. And you can see here just like seal range and nugget here, seal range and nugget here. And now you can see like we define custom function called an spherical variogram, and it calculates the theoretical variogram also, and then we extract legs and empirical semivariance calculated during the Kriging step. Here you can see we have the empirical semi-variogram plot, and which help us validate an accuracy of our spatial model. And this is the black dots and represent empirical semi-variance and meaning like how our this meaning like how our elevation values actually vary with distance between measurement points. And blue line theoretical model and theoretical model based on statistical variogram we choose AGR. And then here just now we are the final and most visual step and creating elevation surface steps as surface maps using both Kriging and global linear regression model. Yeah, here you can see this is like the final comparison between two surface prediction methods, Kriging and global linear regression. And on the left is Kriging surface, on the left Kriging, and right surface is like very smooth and detailed predictions, and north arrow north arrow not uh, northern arrow it's color bar color bar, and global linear model surface more uniform and less detailed. And also here just explain this is the code generated the two surface plot we just like saw, one for Kriging and one for the global linear model. We first train linear regression and x and y z and predict elevation values and reshape the predicted values. And now again you can say final output a direct visual comparison of two surfaces and prediction models over the same area. And left side Kriging model is high resolution and detailed like surface, and on of the right and global linear model like is smoother and simpler and misses finer and elevation changes. We added a narrow north narrow and for orientation and also color bar. Here just I explain the Kriging model give us a much more detailed and accurate surface, capturing local elevation changes, and also global linear model was smoother but amidst the fine variations it just assumed uniform trend and Kriging is a better for geospatial analysis because it considers spatial relationship and even predicts error and estimates for reliability. And reliability, if were to collect more data, our target to Kriging model showed high prediction error, usually near the edge or place with fewer some sample like points. So this is all of my project. Thank you, sir. Thank you so much. Um, bye. Goodbye.